Now, another strategy that we're going to use when solving problems involving permutations is the rule of sum. When one event or another event occurs, we use the rule of sum. Now, recall that events that cannot occur at the same time are said to be mutually exclusive. And so then cases when that occurs, then we're going to be using the rule of sum. At an international conference, either 8 or 9 countries may attend. So in this case, it's either going to be 8 or 9. It can't be both 8 and 9. So these events are mutually exclusive. In how many different arrangements could the country's flags be flown? So we're going to use the rule of sum here. And the method we're going to use now is we're going to determine the number of ways that we can, or the number of arrangements will be equal to the number of ways we can fly 8 flags plus the number of ways we can fly 9 flags. Now, we can use a permutation here, method here, or we can use factorial notation. So now, if we are going to use permutations, this is 8. The permutation of 8, choose 8 because we're going to choose all 8 countries to flags to be flown, plus 9, the permutation of 9, choose 9, because if 9 countries attend, we're going to choose all 9 flags to be flown. And the number of ways that we can fly 8 flags then, if you recall that the permutation of 8, choose 8 will be 8 factorial over 8 minus 8 factorial, which is 0 factorial, and that's equal to 8 factorial, plus the number of ways we can fly 9 flags, which is 9 factorial over 9 minus 9 factorial, which is 9 factorial. So we're going to use our calculator here. It's going to be 8 factorial, which is 40,320 plus 9 factorial, which is 362,800, and that's equal to 403,200. Now, part B of this question said, in how many different arrangements could the flags be flown if the host country must be on the left? Well, if the host country must be on the left, so this is part B, then the first spot, the spot on the left, is going to be taken up. So then the rest of the 7 flags, if there's 8 countries attending, then it's going to be the permutation of 7, choose 7, plus the permutation of 8, choose 8, which is 7 factorial plus 8 factorial. So 7 factorial is 5,040 plus 8 factorial, which is 40,320, and that comes out to be 45,360. So another example where we can use the rule of sum, a security code consists of either 5 or 6 different, and the key word here is or, and different letters, and they're not case sensitive. How many distinct security codes are possible? So the number of codes since we're only using letters, then it's going to be the permutation, we've got 26 letters to choose from. There doesn't say that there's any restrictions. So we're going to choose, of the 26 letters that we have to choose from, we're going to pick 5. But we could also have 6-letter combinations. So it's going to be 26, choose 6, permutation of 26, choose 6. And because the code's order is important, we have to use permutations. So this is going to be equal to 26 factorial over 5 factorial plus, 26 minus 5 factorial plus 26 factorial over 26 minus 6 factorial. And this simplifies to be 26 factorial over 21 factorial plus 26 factorial over 20 factorial. And when you use your calculator, this is going to be 26 factorial divided by 21 factorial. And that's 7,893,600 ways we could have 5-letter codes for the security code. Plus, if we choose 6 letters, then it's going to be 26 factorial divided by 20 factorial. And that comes out to be, and subset. $173,659,200. So that's the number of codes if you're going to use either 5 letters or 6 letters.